Okay, guys, so today we're going to talk about a different way to solve systems algebraically. This should be a new method. You haven't seen it before. So we're going to do the definition first and then get going into the notes and the examples. So today we're going to talk about the elimination method. And the elimination method of solving a system is when you solve a system by eliminating one of the variables. So it's similar to substitution in that we are trying to get just one variable in the equation so that we can solve for that one and then plug it back in. But we're going to do something a little bit different. So the first example that you're just going to put in your examples page is a simple example, but we'll get more into it in just a second. If I have a system y plus x equals 2 and y minus x equals 4, I notice that this is a positive x and this is a negative x, and if I add the two equations together, y plus y gives me 2y, and x plus negative x gives me 0. So those variables eliminate. 2 plus 4 gives me 6, and then I can solve for that one variable that's left. And that's the elimination method in a nutshell, but we're going to get a little bit more into it with a lot of different examples. If at any time I am going too fast and you need a little more time to write it down, just pause the video and you can catch up. So let's talk about 4.3. We're going to solve a system using elimination. So the first thing about using elimination is we want the x and the y to be on both sides, on the same side of the equal sign. So that means we actually want to make sure that the equations are in standard form. And that's if necessary, so if it's not already in standard form. Then the thing about elimination is we want the coefficient of one of the variables to have the same number but be opposite in sign. So we want the coefficient of one of the variables in each equation, and they should only differ in sign. So you will multiply if necessary to get the signs different or the numbers the same but opposite signs. So then step 3 is you will add the equations straight down to eliminate one of the variables. And that will get you a variable solved for, so either x or y. It will differ every time. But then after you solve for that variable, you can substitute the found value back into one of the original equations and solve for the missing value. And then, as always, you want to write your answer as an ordered pair. So let's look at the first example. 2x plus 5y equals 17, and 6x minus 5y equals negative 9. So when I'm looking at the system, I'm looking at the x's, and I have 2x and 6x, and then I notice that the y's, I have plus 5y and minus 5y. So those have the same coefficient but opposite signs. So I'm going to add straight down, and I'm going to end up eliminating the y's. So I have 2x plus 6x gives me 8x. 5y minus 5y gives me 0. So those eliminate. Equals 17 plus plus negative 9 gives me positive 8, or 17 minus 9 gives me 8. And then I solve for this. So to solve for x, I divide both sides by 8, and I get x equals 1. But I have to solve for y too. Here I only have the x. So I'm going to take this x equals 1, and you can plug it back into either of the original equations. It does not matter which equation you plug it into. I'm going to plug it into the first one, 2x plus 5y equals 17. So that's going to give me 2 times 1 plus 5y equals 17. So that's 2 plus 5y equals 17. Subtract 2. So 5y equals 15, and then divide by 5. And I get y equals 3. So my ordered pair is 1, 3. So I'm going to skip 2. I want you guys to do number 2 on your own. For the recording, I'm going to move on to 3, but I will leave the worked out answer key with the sub so that you can check your answer to number 2. So let's move on to number 3. I have a negative 3x minus 3y equals 9, and 3x minus 4y equals 5. So in this case, I have a negative 3x and a positive 3x, so those will eliminate. So I'm going to add straight down. Negative 3x plus 3x gives me 0, so those eliminate. Negative 3y minus 4y gives me negative 7y equals 9 plus 5 gives me 14. So I'm just adding straight down. Then I divide both sides by negative 7. And I get y equals negative 2. So this time I have y, so I need to plug it back in and solve for x. I'm going to plug my found value into the second equation. So I'm going to use 3x minus 4 times negative 2 equals 5. So that gives me 3x. Negative 4 times negative 2 is plus 8 equals 5. Subtract 8. So 3x equals negative 3, and when I divide both sides by 3, I get x equals negative 1. So my ordered pair is always x comma y. So negative 1, negative 2. So let's look at number 4, and let's talk about what happens if I have the same coefficient, but they're not opposite. So number 4, I have 3x plus 3y equals 27, and I have negative x plus 3y equals 11. So I notice that I have a 3y and a 3y, but I don't have opposite signs, so I can't add these to eliminate them. So what I have to do is multiply one of the equations by negative 1 to get the sign to be opposite. So I'm going to do the bottom one, but it doesn't matter, you can do either one. And I'm going to multiply by negative 1. So what I want you guys to do is off to the side, I just want you to rewrite the equations. So the first one doesn't change at all. 3x plus 3y equals 27. when I multiply this equation by -1, -1 times negative x gives me positive x. -1 times 3y is -3y. And -1 times 11 is -11. So now when I add those equations, 3x plus x gives me 4x, 3y minus 3y eliminates, and 27 minus 11 gives me 16. Divide both sides by 4, and I get x equals 4. So when I plug that back in, you can plug in your found value to this first equation, to the original second equation, or even to the new equation after we multiplied by -1. I'm just going to plug it back into the original. So that's going to be negative x, which is 4, plus 3y equals 11. I'm going to add 4 to both sides. So 3y equals 15, and then divide by 3. And I get y equals 5. So my ordered pair is 4, 5. So you will do the exact same thing on numbers 5 and 6. You're going to have to multiply one of the equations by -1 so that they cancel, or so that they'll reduce or eliminate, sorry. But I want to show you the other problems, but I will leave the answers with the worked out solutions so you can check them. So let's look at number 7. So number 7, I have -2x plus 15y equals -32, and 7x minus 5y equals 17. Nothing eliminates here straight off the bat. So when I notice that when I'm looking at my x's and I'm looking at my y's, I don't see anything that will eliminate very easily. However, if you notice, we can multiply equations by a value to get one of the variables to eliminate, like we did in the previous one, in number 4. So I look at my x's and I look at my y's, and I notice that my 15y, I have a -5y in the other equation. So they have opposite signs already, which is good for me. And I can easily multiply this equation to make that 5y into a 15. So that's what I'm going to do. So I'm going to multiply the bottom equation by 3 and watch what happens. So I'm going to rewrite this one. Three times 7x gives me 21x. 3 times -5y is minus 15y, and 3 times 17 is 51. So then we add straight down. -2x plus 21x is 19x. 15y minus 15y eliminates, which is what we wanted to happen, equals -32 plus 51 gives me 19. Divide both sides by 19, and I get x equals 1. So then I'm going to take that and plug it back in to one of the original equations. And I think I'm going to plug it into the top one. So I'm going to get -2 times 1 plus 15y equals -32. And again, you can choose any equation. There's not a right or a wrong one to choose. it's going to give you the same y value no matter what. So then I'm going to add 2, and I get 15y equals negative 30. Divide by 15, and I get y equals negative 2. So my ordered pair is 1, negative 2. Eight and 9 are very similar, the exact same thing. So let's look at number 10, and then I'll let you guys work on the rest of the problems, and the sub will put the answer key under the .cam for you to check when you are done. So number 10, last thing is 3x plus 2y equals 1, and 4x plus 3y equals negative 2. When I'm looking at my x's, nothing is opposite and nothing will eliminate easily. And when I'm looking at my y's, it's the same thing. They're both positive and neither one will eliminate easily. So what we're going to end up doing is multiplying both equations by a value so that we can eliminate one of the variables. And one of those multiplication factors is going to have to be negative. So I have a 3x and a 4x, and I can easily make those into 12s. And I have a 2y and a 3y, and I can easily make those into 6s. So it really doesn't matter what you multiply by or which variable you eliminate, as long as they do eliminate. So for this example, I'm going to do 12. So I'm going to multiply the top equation by 4 and the bottom equation by 3. So that's going to make those x values 12. But one of them has to be negative because we want them to eliminate. So I'm just going to make the 4 negative. So negative 4 times 3x is negative 12x. Negative 4 times 2y is minus 8y equals negative 4. And then I multiply the bottom by 3. So that gives me 12x plus 9y equals negative 6. So when I add straight down, negative 12x plus 12x eliminates. Negative 8y plus 9y gives me positive 1y. And negative 4 minus 6 gives me negative 10. So I have y equals negative 10. When I plug that back in, so you can use any equation to plug it back in. I'm going to plug mine back into the original top equation. So 3x plus 2 times negative 10 equals 1. 3x minus 20 equals 1. Add 20. And I get 3x equals 21. So x equals 7. So my ordered pair is going to be 7, negative 10. So on 11 and 12, those are going to be problems where you have to multiply both equations. So like I said, work on the remaining 7 problems that we did not do yet in class, and the sub will put the answer key on the .cam when you guys are done so you can double check. Okay? Have a great Thanksgiving. I'm not going to be here on Friday either. I'm on a field trip. So I hope you guys have a good Thanksgiving and a good restful break, and I will see you when we get back.